Welcome to video 10.1c, some more radius-chord relationships. These will be some more challenging examples, so let's get right to it. So in both of these more challenging examples, we're going to have to draw some auxiliary lines and reach back and make relationships between the theorems we just learned. All right, so given circle O with, let's label this, PQ is 4, RQ is 10, and PO is 15. Find PS, that's that little question mark right there. Okay, so let's start with the end game. The end game would be, once I find OS, I can get PS by mere subtraction. Ooh, OS happens to be a radius. So if I could find the radius, I can solve this problem. So my game plan is really to find the radius. Okay, let's go about doing that. The theorems we dealt with before dealt with going from a center point perpendicular to a chord. So why don't I draw an auxiliary line that does that? I can do that. I just did. Oh, and if I'm perpendicular, I know I bisect that chord. So that whole chord was 10. I now have a 5 and a 5. Ooh, it looks like I've got a right triangle over here. I'll highlight it in red. And it looks like this whole length here is 9, and that whole hypotenuse is 15. That kind of reminds me of something. 3, 4, 5. Let's multiply each number by 3. 9, 12, 15. So we got a 9 there and a 15 there in the hypotenuse. This must be a 12. Okay? Now, let's try to find the radius. That was the end game. Ooh, let's draw another auxiliary line, and that is the radius. Once I find that, I've got that, and then I can get that. Oh my gosh, I have a 5, 12 something. Oh, I think that was a 5, 12, 13. So this is 13. So this is 13. So 13 plus what number makes 15? That would be 2. Just to show my work, PS equals 15 minus 13 equals 2. Whew. All right, let's try the next example. An isosceles triangle is inscribed in a circle. That means each vertex point lies on the circle. Each leg of the isosceles triangle is 13. I've drawn that as such. The altitude to the base of the triangle is 5. Remember, altitudes are perpendicular. Find the radius of the circle. Okay, well what I'm going to do here is I'm going to call this x, and then if I do that, just so you know, the radius equals x plus 5. So once I find x, I've got the radius. It's just x plus 5. So now my end game is somehow to find x. Okay, well, let's just talk about this right triangle here. Again, I'm familiar with a 5, 12, 13, so this would be 12 right there. Then, I'm going to do something crazy. I'm going to draw another radius. So just to let you know, that's a radius there, and that's a radius there. Ooh, and I know that that radius is x plus 5. So now I've got a right triangle with legs of x and 12 and a hypotenuse of x plus 5. I can now use the Pythagorean theorem. So the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Or in this case, x squared plus 12 squared equals x plus 5 squared. lot of students struggle with this. It is not x squared plus 25. You gotta FOIL it out. X squared plus 144 equals x squared plus 5x plus 5x plus 25. Again, it was just x plus 5 times x plus 5 doing FOIL. And 5x and 5x is 10x. I'll just put that in there. All right, well, I can cancel an x squared from each side, so it's no longer a quadratic, it's just a linear. That makes it much easier. So let's see what I've got here. I can take the 25 away and say 119 equals 10x. I can divide each side by 10 and get x to equal, that would be 11.9. All right, I don't care about x, so again, the 3 steps. Let's review. Set up the equation, solve the equation, and then answer the question. So the radius is going to be x plus 5 equals 11.9 plus 5, and that's going to be 16.9. Whew. So there you have it. 2 more challenging examples on radius chord relationships.